Hello guys, welcome back for another question from Inverse Trigonometric Functions chapter. So let's directly dive into the question without wasting any time. So what we have here, this is a proving question, and on the left hand side we have something as tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8 is equal to pi by 4 on the right hand side. So we can see that as soon as we get the idea that pi by 4 is written on the right hand side, we know that pi by 4 is equal to tan inverse of 1. So that gives us an idea that we have to consolidate all these four terms into a single tan inverse term, and that can be done with the help of formulas. Tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus x plus y. So now moving to the next step, what we do, we first take these two steps and apply the formula. So our x is equal to 1 upon 5, our y is equal to 1 upon 7. So our answer comes as tan inverse of 1 upon 5 plus 1 upon 7 upon 1 minus 1 upon 5 into 1 upon 7. Further simplifying the terms, we get two terms consolidated as tan inverse of 6 by 17. Now we take these two terms, tan inverse 1 upon 3 plus tan inverse 1 by 8, and our x is 1 upon 3, y is 1 by 8. So applying the same formula here as well, we get a consolidated term as tan inverse of 11 by 23. Now we can again apply the same formula on these two terms, where x is equal to 6 by 17 and y is equal to 11 by 23. Moving to the next slide. So what we do, we again apply the formula where our x was 6 by 17 and our y was 11 by 23. So we get our answer as tan inverse of x plus y upon 1 minus x into y. Simplifying further, we get tan inverse 325 upon 325. That makes it tan inverse of 1. And wow, we get our answer as pi by 4, as we discussed in the very beginning of our video that pi by 4 can be written as tan inverse 1, and our actual result that we got was tan inverse 1. So we can see that LHS is equal to RHS, and we have proved our expression. I hope you all got it. Thank you.